I'm William Brown, and I'm for Team Skynet, and I'll be doing a demo of our climate change predictor. And the first thing we have to do is train the model. And what our project does is it takes the last 3 years of data from New Orleans and uses that data to predict the climate for the next 3 years. And the data it uses is average wind speed, average temperature, and average precipitation. So as you can see, these are history values, and these are the true values. So this is what we're training the model to predict is these values. And these values are the monthly temperature of New Orleans. And these are the features we're using. So this is average temperature and average wind speed and average precipitation. And you can see we use data from about 30 years. And now we're going to train the epoch. And this is how we train. So you can see we're going to train for 50 epochs and 29 steps, and we're going to validate for 8 steps. So as you can see, as it goes through the time steps and trains, the training loss will go down. And when it finishes, also the, the validation loss will also go down. And these two numbers will decrease more and more as the epochs training get closer to 50. And we want these numbers as close to 0 as possible to get the best results. This training process can take a while, so I may skip to the end. So as you can see, we're almost done training. We're on our last epoch, and both the training and the validation loss have both steadily decreased through the training process. And they're starting to plateau out as we finish up our training. So as you can see here, this is the mapped training and validation loss, and you can see it plateaus out with no overfitting. It never goes back up, and so this looks good. This looks like we maximize the potential of our neural network. And this is how well our our model predicted the future values. So the blue ones are still the actual values, and the red is what the model predicted. So as you can see, it did pretty good. And it did that for each feature. So this feature looks good as well. And one more time. So, and then this also looks well. So the model clearly trained and is able to predict the future values. And these are our error terms. This is how we describe our accuracy. So our mean absolute error was about 1.98, and we want that as close to 0 as possible, and that's not bad. And the mean squared error is obviously going to be larger than this, and this is more of about how far off of the actual values we were total. So it's about 6. And this is the R2 score. So what this means is our model trend is about 80% correct or 81% correct. And these three uh, measurements are the standard of accuracy for neural networks. And now that we have our model, it's also saved inside of our project. So As you can see, this is saved at 10:59 a.m. and it's 11:02. So this was just saved recently, and we're going to need that model to predict the next 3 years for New Orleans climate. So now we have a model, we can go ahead and run our actual climate predictor. Okay, so here we're going to use the data from 2017 to 2020 to predict for 2020 to 2021 and 2022. And this is the wind speed and the temperature and precipitation. And as you can see, there is some correlation. As the wind speed drops, it seems like the temperature increases. And also there could be some correlation between the precipitation and the temperature. You see, as precipitation rises in some areas, temperature also rises. And our model predicted the degrees Celsius for 2020, 2021, and 2022, and an average for each month. And you can see the general trends of the temperature based on the features we chose. And another thing this project does is it saves that data inside of an Excel sheet. As you can see, it's just 11:03 a.m. It's 11:04, so this was just saved. And if you open it, it organizes the data well, and with the year and the month and each degrees Celsius of that specific value. So that is what our project does, and I would like to thank you for watching. Thank you.